All right, here's the big one, the unit circle. No calculator. Could not stress that enough. Do not use a calculator for this section. Let's get going. So I'm giving you a quarter of a circle. It's going to be in quadrant 1, and it's a unit circle, which means that the radius length is going to be 1. So again, the radius is 1 unit. There's specified degrees here. We're going to go and change these values to radians, these degree values to radians, and we're also going to find the coordinates of these values because we're able to with special right triangles. So let's see what we can do with this. 0 degrees is going to be 0 radians or 2 pi radians. The way I know it's 2 pi radians is that if I had a full circle and the radius is 1, well, the entire length all the way around the circle would be 2 times pi times 1, which would be the radius, which gets me 2 pi. That's how I know that this terminal side could be 0 radians or, in a full circle, 2 pi radians. The coordinate for this point is going to be, well, I'll do the coordinates afterwards, actually. Let's keep it organized, Mr. Lakin. 30 degrees, I don't know if we found that in the last one, but you can pause the video to check this on your own. This should be the same thing as pi over 6. 45 degrees, we found this one in the last video, was pi over 4 radians. 60 degrees is going to be pi over 3 radians. 90 degrees, it's a quarter of the circle, but multiplying it by 2 pi for the full circle gets us pi over 2. If you're not sure what I meant by that, a quarter of the circle is 90 degrees. So I need 1/4 of a full circle, which was 2 pi, which gets me pi over 2. Okay, well, look at that. That was easy. We took care of the radian equivalents for each of those. Now, let's go in and find the coordinates. Again, the radius of the circle is going to be 1, which means this coordinate here, and let's use a different color now, this coordinate here is going to be 1, 0. Now this one is going to be a little bit different. It's a 30-degree angle that's being made. We know that the radius is 1. And when I say 30 degrees, I mean pi over 6. So what's the height? And let me redraw this because that was a silly error on my part. We have this green triangle. We have a right angle. We actually don't know the length of the horizontal side. We also don't know the length of the vertical side. We do know that we have a 30-degree rotation, or pi over 6, and we know that the radius is 1, and the radius is going to be the hypotenuse here. Now it's a 30, 60, 90 triangle. It's a special right triangle. And I know that my hypotenuse is twice the smallest side. The smallest side is y. So if 1 is already twice the smaller size, y has to be 1/2. Now that I have the smallest side times root 3 is going to give me root 3 over 2. As a coordinate, I'm going to have root 3 over 2, comma, 1/2. I can actually take care of the 60-degree one because the 60-degree just means that instead of the 30-degree angle being at the base, the 60-degree angle is going to be at the base. If the 60-degree angle is at the base, that means that the coordinates switched. And hopefully that's somewhat intuitive, that we have to have the smaller of these two numbers in the x-coordinate, the larger of these two coordinates in the y. So the coordinate for 60 degrees is going to be 1/2, comma, root 3 over 2. I'm going to keep the easiness going here, and let's take care of the 90 degrees. Nothing moved in the 0 in the x. In the y, the radius is 1. I should have noted before, this is part of the first quadrant, and this corner here is the origin. And I don't know if that was immediately clear. I didn't specify that the center was the origin, so my apologies if that was confusing. Finally, pi over 4. We're going to clear this out. So for pi over 4, I'll use purple for this one. Again, I know that at the base, the angle is opening up pi over 4, and I know that my height is going to be, my hypotenuse is going to be 1. Remember, these two sides are congruent. So if I do Pythagorean Theorem, I get 2x squared is equal to 1, which means x is equal to 1 over root 2, or root 2 over 2, if you rationalize. Which means that the x and the y, because remember, x is equal to y here, since we have an isosceles triangle, is going to be 1 over root 2 for both the x and the y. And that's it. That's the entire first quadrant. So why do we care about this? Well, we care about this because we can use something called reference angles. And when we look at the next slide, or when you look on into your sheet, you'll see some problems that are going to be like sine of 5 pi over 6. The unit circle is going to help us with this because all we have to identify is a particular coordinate to solve the problem. So again, reference angles and trigonometric evaluations is going to be why we want the unit circle. So let's go through the reference angles. We already said that this was 0 or 2 pi. We already said that this was pi over 6. We said this was pi over 4. This was pi over 3. And this was pi over 2. So how much is this one? Well, this angle is going to be, it looks exactly the same as pi over 6, doesn't it? And that would be correct. We're going to use pi over 6 as a reference angle, and a reference angle is an acute angle, which pi over 6 is, where the terminal side of an angle in standard position makes with the x-axis. So this angle here is going to be our reference angle. This angle relates to pi over 6. If we go all the way halfway around, if we go halfway around the circle, the entire circle is going to be 2 pi radians. Up to here is going to be pi radians. If I go from pi backwards, pi over 6, I end up getting pi minus pi over 6, which is going to be 5 pi over 6. So the radian measure here is 5 pi over 6. And a lot of students have a hard time memorizing which angle is what in this. And if you just remember the reference angles and the location from pi or from 2 pi, you can find these fairly easily. I'm going to use that word cautiously. Here in the green is going to be for pi over 4. And it looks like we just went backwards pi over so. So pi minus pi over 4 is going to be 3 pi over 4. We can repeat for pi minus pi over 3. And 3 pi over 3 minus pi over 3 is going to give us 2 pi over 3. Similarly, if I go clockwise, pi over 6, I subtract. If I go forward, pi over 6, so if I go backwards or counterclockwise, pi over 6, then I just have to add pi over 6 to pi. So pi plus pi over 6 is going to be 7 pi over 6. And that's what I'm going to be doing throughout here. I'm also going to do pi plus pi over 4 because this angle looks about the same as it would in the first quadrant using that reference angle. So pi plus pi over 4, that's going to be 5 pi over 4. And finally for this one, I'll leave the math to you. That's going to be 4 pi over 3. Let me change the color. Now, we have a 0, we have 1/2 pi, we have a full pi. This one's going to be 3/2 pi. And then finally, we can do 2 pi minus pi over 3 to get this angle in blue. So 2 pi minus pi over 3, that's going to be 5 pi over 3. And I'm going to leave the rest to you. That's how we're going to get 7 pi over 4 and 11 pi over 6. I'm going to change the colors so they line up with the reference angles. And again, the reference angles will only be those angles in the first quadrants. Let's see, we have a green. And we have a red. Now, I'm not going to fill in the angles here, but I'll fill in the coordinates. Notice again, the coordinates look like they're in about the same position as the angles in the first quadrants, which is exactly what we want to identify. The only difference is the signs are going to change. So here, you have your x values are negative, but what your y value is positive. So here, we're going to have negative 1/2, and we're going to have the y value will still be positive. No difference here. For the third quadrant, both signs are going to be negative. For the fourth quadrants, your y signs are going to be negative, and your x's will be positive. And see if you can fill in the rest of the unit circle. And I'm going to have the unit circle with all the angles, the radians, and the coordinates completely filled in. And hopefully that's what you were able to get once you filled in the entire unit circle. Okay, the last thing that I'm going to say for this portion of the video, reference angles are going to prevent a lot of repetitive work, so all you really need to know is the first quadrant, which is why we did that. Quick tip for you in the future, cosine always relates to x, sine is always going to relate to the y coordinate on the unit circle, and the tangent is always going to require the ratio y over x.